In this video, I'll show you how to create a simple 2D game in Unreal Engine 5 from scratch. We'll go over importing sprite sheets and tile sets, creating a small stage with tile maps, setting up a character, animation switching between idle, running and jumping, and also the best settings and best practices when making 2D games in Unreal Engine. We'll also make many improvements to the movement settings to make the character fun to control. I already made a video on this topic about a year and a half ago that got over 600,000 views. However, a couple of things have changed with Unreal and I also made many improvements to the workflow, so this will be the definitive Unreal 2D video for beginners for 2024 and onward. For this tutorial, I'll use Unreal Engine 5.3, which is the current version. But if you watch this video at a later time, you should also be able to use any version newer than 5.3 as well. In the project browser, click on Games, and here we have a bunch of different templates. Sadly, there is no 2D template with Unreal Engine 5, and the ones you see here are custom templates I made by myself. If you're interested in these, there's a link in the description where you can get the basic template for free and the 2 advanced templates as a patron. But for this tutorial, I want to show you how to make a 2D game from scratch, so let's use the blank template and leave all of the settings on the right as they are by default. We want this to be a blueprint project for desktop with the maximum quality preset and no ray tracing and also no starter content. Then give the project a name and click on Create. Once it's done loading, you can see this huge open world map, which we're not going to use. We want to first create a small 2D stage which our character can stand on. Click on File, New Level, and select the empty level and click on Create. We don't want to have any lighting or sky sphere, so this is perfect for making 2D stages. To make sure the stage doesn't disappear, we'll have to save it. Click on File, Save Level As. In the content folder, create a new folder called Maps. Change the name of the map to map_2D and save. We now want to set this as the default map. Go to Edit, Project Settings, and on the left side, click on Maps and Modes. For the editor startup map, we now want to select this map_2D. And also for the game default map, we want to select map_2D. This just makes sure that this is the first map which is loaded when we open up Unreal Engine or make a build of the game. One more important setting I want to change right now before we import assets is the pixels per unit setting. By default, this is 1.0, which means that 1 pixel for a sprite is 1 Unreal Engine unit, which is 1 centimeter. In most cases, this is much too small though, and since our character is 48 pixels tall, it would only be 48 centimeters tall in the game, which is way too small for a human. This would cause some issues with settings such as the step height and would allow us to teleport up and down ledges, which is something we definitely don't want. I believe making the character about 3 times as tall should suffice and make it about 145 centimeters, which is in a reasonable range. And if we type in 0.33 here, that will achieve the effect of scaling up our pixel art by 3. Now for all of the assets we'll import and create after this, the new pixels per unit setting will be applied. The asset pack we're going to use for this video is Legacy Fantasy by Anokolisa, which is completely free and distributed under a CC0 license. Since the asset pack is huge and has many things we're not going to use, I prepared everything for easy usage with Unreal Engine and made a repack of the files. Please download this from the link in the description to follow along. This link will lead you to a Patreon post where the files are hosted, but everybody can download these even if they're not a member, so don't worry. Just click on it to download the zip file. After that, you'll have to right-click the archive and unzip the files. Here we have the character folder, which has the sprite sheet, and the environment folder, which has a few tile sets. Back in Unreal Engine, let's prepare a folder for this. Open up the content drawer and right-click, create a new folder called Paper Assets. We can now just select both the character and environment folder and drag them into our Unreal Engine window. This should work out for most of you, but a few people might have some trouble with this and are unable to drop the files into Unreal Engine. In that case, you can try using the import button on the top left of the content drawer, which usually works around that issue. Now that we have all of our textures in Unreal Engine, let's have a look at the environmental assets. If you double-click the T_tiles main texture and zoom in, you can tell that something is off and it looks very blurry. This is because the default settings for textures introduce texture filtering and other settings that don't work well with pixel art. To work around that though, we only have to right-click the texture, go to Sprite Actions, and apply Paper 2D Texture Settings. This will update the settings to be ideal for pixel art, and you can see that when we zoom in. Select all of the other environmental textures as well by holding Shift and clicking all of them, and apply the Paper 2D texture settings to them as well. To use these textures with a tile map, we first need to convert them to tile sets. Let's start with the one on the right, which is T_tiles main, and right-click it. Go to Sprite Actions and create tile set. Double-click the newly created tile set to open it up. Here in the tileset editor, there are only a couple of things we have to do before we can use these tiles in the game. The first thing we need to figure out is the tile size. We can see here on the right side that it's set to 32 by 32 by default. However, if we click around on the left side, you can see that the size of the square doesn't really match the tiles themselves. Sometimes the asset creator will mention the tile size, but other times you'll just have to use some trial and error to figure it out by yourself. For this asset, I know that the correct size is 16 by 16, so we can just type that in. Now that we have the correct tile size, the only thing left to do here is assigning the collision to the tiles that need it. Let's start from the top left. In the case of this asset, we actually don't want to assign collision to the topmost grass layer, because we want the character to nicely stand on top of the grass and not float above it. So let's assign collision starting from the second row. We can simply click on Add Box to add a box collision here. On the right side, we could also make some adjustments, but the default is fine here. Let's click on the next tile and also add a box here. The problem we have now is that it's quite hard for us to tell what we've already assigned collision to and what we still have left to do. We can click on colliding tiles on the top left to show what already has collision. And now let's just continue adding box collisions to this one platform. After we're done with that, we can have a look at all of the other things in the tile set. Some of these are just background elements that don't need collision, so we can just ignore them. Other things like this platform would also need collision, but we're not going to use it for this tutorial, so we're just going to ignore it. We're only going to use this grass platform we already created, and I also want to use the bridge. So for the bridge, let's also quickly add some box collisions for the bottom row here. And that's it for tileset collision. The other three textures are only for decoration and don't need collision. However, we also have to convert them to a tile set in order to use them for a tile map. Select all three of them by holding Shift, right-click one of them, go to Sprite Actions, and create tile set. For these, we don't have to do anything else. Now let's create a tile map which allows us to use these tile sets we created as a brush to draw a stage. Look for the T_tiles main_tile set, right-click it, and click on Create Tile Map. I'll just call it TM_stage. Double-click to open it up. One thing I have to tell you about this tile map editor is that it's actually quite prone to crashing, and the crash mostly happens if you try to close the tile map window. So if possible, just try to always keep this window open and make sure to save frequently. With that out of the way, let's start making a very simple stage which our character can stand on. Here in the middle you can see our tile map area in which we can draw, however right now it's very small. On the right side I want to set the map width to 50, and also set the map height to 50 to give us some room to work with. Now on the left side we can just select the entire platform which we applied collision to use it as a brush. And then I want to place it somewhere near the bottom of the tile map, but not all the way at the bottom. Then I just want to place the bridge here. And place another platform next to it. Now I overwrote a small part of the bridge, so I'm just going to get the brush again and draw over this again. And now we have two platforms and a bridge with working collision, which our character will be able to use. I don't like having no background though, so I want to implement another layer. On the top right you can see a list of the tile layers, and we're currently on layer 1. Right click this and rename it to Gameplay to make it very easy to understand what this is used for. Click on the plus icon to add a new layer, right click and rename it to Background. Now on the left side we can click on this array looking icon to select our active tile set. Select the T_sky_tile set. First let's just select one of these neutral blue tiles, and I want to fill up the entire background with these. So instead of the paintbrush I want to select the fill tool. And while we're on the background layer, just left click. Our platforms have now disappeared and we need to click on the down arrow to rearrange the layer order. And now we have a small stage with a background. Don't close the tilemap window because, like I said before, there's a risk of crashing Unreal, but go back to the map. And now from the content drawer, we can just drag out this tm_stage tilemap. Just to keep things organized, I want to reset the location to the default, so we can just click this reset arrow to set everything to 0, 0, 0. One cool thing we can do to visualize the collision is to click on Show and Collision. Now you should be able to see these collision boxes where we set them up, and this can be very helpful for debugging. One more thing about the tile maps and tile sets. It might not be apparent right now and might also not happen for everybody, but in some cases we'll get some really nasty gaps and tile tearing that we need to take care of. There is a very easy solution, and I advise you to do it either way, even if you don't have any issues right now. In the content drawer for all of our tile sets, we want to condition the tile sheet texture. This will add some padding which prevents the tile tearing issue. Let's do it for the t_tiles main_tile set first. Just keep the name and press enter. And you might see some visual artifacts in the map for a second, and that just shows you that the changes have been applied. Now also do this for the other 3 tile sets one by one. And for now, this is all the work we have to do when it comes to the stage, and let's now get to the most exciting part, which is the character. In the content drawer, go to Paper Assets and Character. At this point, this is still just a texture of a sprite sheet. However, to use this in the game, we need to extract the separate sprites from it and also create our flipbook animations. First, we want to apply Paper 2D settings again to make sure this pixel art isn't blurry, but appears crisp. Then right-click the texture, Sprite Actions, and Extract Sprites. You can navigate this area on the left by holding right-click and dragging around, and you can also zoom in with the mouse wheel. This modal will assist us in extracting our sprites, and our goal is basically to have a yellow box around every animation frame and also make sure they are all of the same size. Right now we have the sprite extract mode of auto selected, however this rarely works out and isn't very reliable. Change this to grid. Now all of the frames are in a single yellow box, which again is not what we want. We need to know the size of each animation frame, and sometimes the asset creator will provide a value for that on the download page. However, the easiest and most reliable way to get this number is to just calculate it right here in this field. Let's start with the cell width. The full width of the texture is 200, as we can see here, and we just have to divide this by the amount of columns. In this case, 1, 2, 3, 4. So we can just write 200 divided by 4 right here in the cell width field and press enter. And then do the same thing for the cell height. Here we have a full texture height of 280, and again we have 1, 2, 3, 4 rows. 280 divided by 4 is 70. And now all of these cells line up perfectly. There are some other settings here, such as number of cells, margin, and spacing. However, if the sprite sheet is set up correctly, you won't have to fiddle around with these. Now just click on Extract, and you should be able to see all of these separate sprites. In this case, we also have 2 blank sprites with nothing on them, so we can just right-click them and click on Delete. If you double-click a sprite, you can have a look at all of the different properties. Most of these settings you don't have to worry about. The default material is important, however, if you use a sprite through a flipbook animation, like we will for this character, the material settings on the flipbook will actually have priority and ignore what is being set here on the sprite. The pivot mode will allow you to set the pivot point on the sprite to a specific location and can be useful. However, in this case, we won't need it. But the most important setting by far is the pixels per unit. In simple terms, this will allow you to scale the sprite in relation to Unreal Engine units. Since we already changed this in the project settings before creating this sprite, you can see that it is now 0.33, which is the value we want. Now let's create a flipbook for each of our different animations. A flipbook animation is basically just a collection of sprites that play one after another to give the illusion of movement. We can easily create one by selecting all of the sprites we want included. Click on the first sprite, hold Shift, and select the first 4 sprites for the idle animation. Right-click one of them and click on Create Flipbook. Let's call this FB_player_idle. Now let's do the same thing for the run animation. Click the character_sprite_4, hold Shift, and then click on character underscore sprite underscore 11. Right-click one of them and create flipbook. Call this fb underscore player underscore run. The last two sprites you can see here actually don't belong together. Character sprite 12 is what we want to show when we jump and ascend, and character sprite 13 is the frame we want to show when we are falling. Even though these are just single sprites, we still want to create flipbooks for them for ease of use. Click the character sprite 12 alone, right-click and create flipbook. Call it fb underscore player underscore jump rise. Then click the character sprite 13, right-click and create flipbook. Call it fb underscore player underscore fall. And these are the 4 different animations we're going to implement in this video. Now let's double-click the idle flipbook to check out the flipbook editor. In here you can see the flipbook playing, and you can also pause the playback and scrub through the timeline slowly. The most important setting here is the frames per second setting. If you set this to a low value, the animation will play out very slowly. And with a high value, will play out really fast. In this case, I think a frames per second value of 5 feels about right. Now let's do the same thing for the run animation. Here a value of 5 definitely looks too slow, and I think 9 looks about right for the regular run speed. The fall and jump rise are only a single frame, so we don't have to worry about the FPS setting. Now just to clean things up, we can right-click and create a new folder called Sprites. And another new folder called Flipbooks. And then just separate these. The sprites have a blue line on them and say Sprite at the bottom. Just click one, hold Shift, click the others, and drag them in here. Select Move here. And then just do the same thing for the remaining flipbooks with the green line. We can now close the window for the sprites, but keep the tile map open to prevent editor crashes. Awesome, we now prepared all of the art assets we need for our character. So let's start working on the character blueprint. In the content folder, right-click and create a new folder called Blueprints. Open it up. Right-click again and create a new blueprint class. Out of the common ones, the character parent class is the closest thing to what we want. However, there actually also is a parent class specifically for Paper 2D characters under all classes. Here we can just search for paper and you will be able to see the paper character. Mark it and click on select. Let's call this bp underscore player and open it up. In the viewport, you can see that we have very basic things set up since we inherited from the paper character. We have a capsule component that will take care of our collision with the world. This thing, which is called a sprite, is actually a flipbook component which we'll be using to play back our flipbook animations. And the character movement component makes it very easy for us to set up a character that can move around, jump, and all of those kind of things just by changing a couple of settings. Let's take care of the sprite first. Click the sprite component. On the right side for the source flipbook, we now want to select the fb underscore player underscore idle. Now, since we already set up our pixel per unit settings in the beginning, the sprite is already a pretty good size and almost fits the capsule perfectly. But we can now go to the capsule component and make slight adjustments. For the half height, I think a value of 75 is perfect. For the capsule radius, I believe that 25 feels about right. We don't have to worry about the sword since it's okay for that to stick out and be ignored. Aligning the feet perfectly with the capsule is a bit tricky, but we can slightly move the sprite downward on the z-axis by -2. Now let's place the character in the world and get a feel for what it looks like. Drag an instance of the BP player out into the map and just make sure that it's on the same lane as our stage. The easiest way to do this is to just make sure it's set to 0 on the y-axis. Otherwise, it might not be on the same lane as the collision and just fall down. Now if we start the game, we can see that gravity takes effect and the character nicely stands on the platform. However, we can see a little bit of flickering because the gameplay layer on the tile map and the character are in the exact same position on the Y. A simple fix is to just select the TM stage and on the Y, move it slightly backward. I think setting it to -0.1 is fine. And now when we start, we can see that the character nicely appears in front of the platform. We still can't control the character, however I first want to take care of some 2D settings. In some cases when working with tile maps, if you press on start, everything might start becoming very bright little by little, and also the colors of the scene might look a bit strange. Unreal Engine is of course set up to make 3D games look good by default, and those settings are now fighting against us and we have to make some adjustments. I've struggled quite a while finding all of the right settings, but there is actually a great blog post by UE52D which sums it all up nicely, and I'll use that as a reference. Go to Edit and Project Settings. First look for motion blur and turn this off. This can look very cool in 3D games, however blurriness doesn't go well with pixel art. Then look for anti-aliasing, and for the anti-aliasing method, select None. Anti-aliasing is a technique that removes jagged lines, however again for pixel art this is something we don't want. Next look for auto exposure and turn it off. Also set the auto exposure bias to 0. Next we want to look for global illumination and set the dynamic global illumination method from Lumen to None. Lumen is the new global illumination system introduced in Unreal Engine 5, however since our 2D stage won't have any lights, there is no benefit to using this. Then look for reflection method, and also set this from Lumen to None. Next look for shadow map method, and set this from virtual shadow maps to shadow maps. This is the old method that should be a bit more performant in our case. Lastly, look for ambient occlusion and turn both of these off. Ambient occlusion is a shadowing technique for 3D objects, but again, we don't have any lights and 3D objects, so there's no benefit to using this. All of the other settings we cannot set in the project settings, but have to create a post-processing volume for our level. To create one, we can click on the add icon here, volumes, and click on post-process volume. Just so we don't lose track of it, we want to put it to the 000 location, which we can do by just clicking on this reset arrow. Now we always know where to find it. You can have volumes like these which only affect a certain area in a stage, however we want it to affect the entire stage, so the position doesn't matter. While it's selected, we can just search for infinite and set infinite extent unbound to true. This means it will affect our entire stage regardless of size and position. Now we can take care of the remaining settings. Look for EV100. Both the min EV100 and max EV100 affect the auto exposure and can make the brightness of our sprites inaccurate. We just want to set both of these to 0.0. Next, look up vignette intensity. This creates a darkened rim around the edge of the screen, which is something we generally don't want for 2D games, so set this to 0.0 as well. Next, look for expand gamut. This will affect the colors of your sprites and might make them look unnatural. Set this to 0.0 as well. Lastly, let's look for tone curve. This tone curve amount will again affect the colors of your sprites. In some cases this can look quite good and give the image a bit more contrast, however if you want to keep the original sprite color you want to set this to 0.0 as well. And now our 2D game looks a lot more pure and very close to how the sprites have originally been drawn. So these are some settings you always want to apply to your 2D games. If you end up adding more stages to your game, you just want to copy-paste this post-process volume and place one in each of your stages to apply the same settings. Next up, we want to control the character and set up the camera. Right now, if we click on play, we just have this free-flying camera because Unreal Engine doesn't know which pawn we want to possess and spawns a new default pawn for us. The best way of setting the pawn is to create a game mode. Open up the content drawer, go to the blueprints folder and right-click. Go to blueprint class, and here we have a game mode base which we can use as the parent class. Call this gm_platformer and double-click it to open it up. This is a full-on blueprint which we can use in many different ways, however for now we only want to look at the right where it says classes. And for the default pawn class, select our BP_player to let Unreal know we want to control this character. But now if we press play, nothing has changed because we also need to let Unreal know that we want to use this game mode we just created. Click on Edit and Project Settings. Then on the left side, click on Maps and Modes. For the default game mode, we want to select our GM_platformer. Now if we start the game, you can notice that something is very different. We are now falling and still don't really see what is going on. What is happening here is that Unreal Engine spawns a new instance of our BP player in our current position, however we want to spawn on top of the stage. Select the player we currently have here and hit the delete key on your keyboard to delete it. Then click on the plus icon, go to Basic, and look for Player Start. This is an object that lets Unreal Engine know where we want to spawn our default pawn. We can drag it into position and then also make sure that the green y-axis is set to 0 to line up with the ground. Now if we start the game, we're at least not falling anymore, but we still don't see our character. If you click on eject though and move around, you can see that the character is indeed being spawned and we are possessing it. We just haven't set up our camera yet, so it instead puts us in this weird first-person view. To alleviate that issue, let's open up the BP_player blueprint. While the capsule is selected, we want to click on Add and look for Spring Arm. While the spring arm is selected, click on Add again and add a camera. Now we want to change this to a sideways view. Select the spring arm, go into rotate mode, and drag on the blue axis by -90 degrees. So we now look at the character from the front. Now when we start the game, we can finally get a good look at our character. All of this already looks pretty good, but we can make a few more adjustments. First of all, we want to go to the camera and set the projection mode from perspective to orthographic. The effect of this might not be instantly apparent, but this removes all depth from our scene and creates a more pure 2D look. The orthographic camera actually used to be quite buggy and it wasn't recommended, however it has seen many updates with Unreal Engine 5.3 and will hopefully continue to do so. Now to change the distance of the camera, we cannot use the target arm length on the spring arm anymore. Instead, on the camera we can now change the ortho width. The wider this is, the further away the camera will appear. Let's set this to 700. And you can now see that the camera appears further away. Lastly, on the spring arm, we want to look for Do Collision Test and deactivate this. If this is active and something is between the camera and the player character, it will forcefully zoom in. If you're making 3D or 2D/3D hybrid games, this might be useful in some cases, but for 2D only games, this will often just lead to bugs and confusion. Now that we are possessing the character and have the camera set up, we need to set up the input bindings and allow the character to move and jump. Since Unreal Engine 5.1, the new enhanced input action system has become the default and we'll be using that for this tutorial. It might be a bit hard to wrap your head around at first, but it has a lot of great built-in functionality and will save you a lot of time in the end. Let's open up the content drawer and go into the content folder. Right-click and create a new folder called Input. Open this up, right-click again, and create a new folder called Actions. The input system basically consists of input actions, which are certain actions we want the character to execute, such as move, jump, attack, and so on, and an input mapping context that binds these actions to a certain button and can also apply modifiers. Let's first go into the Actions folder, right-click, Input, and create our first input action. I'll call this IA_jump. When we double-click this, we can see a bunch of options, but the only one we really care about is the value type. Currently this is set to digital bool, which is correct for an action like jumping. This means that the input for this action can either be active or inactive, and that is the case for a regular button. Create another input action called IA_move. Open this up, and here we actually want to change the value type. The move action can be executed with a left or right button on the keyboard, but in many cases we'll also add controller support for the analog stick later on. This means it's not just an on or off value, but it could be a value between -1 for left, 0 for neutral, and 1 for right. Since we only want to support left and right, we want to use the value type of axis 1D float, which gives us a range from -1 to 1 on a single axis. Now that we have both of our actions set up, we want to go back to the input folder. Right-click, go to Input, and create an input mapping context. I'll call it IMC_platforming. Double-click to open it up. In here, we now have to register the jump and move actions we created to bind them to a button. Where it says Mappings, click on the plus icon, and then on the caret to expand the menu. Click where it says None and select IA Jump. Now again, expand the menu, and here we can set up which button we want to use for jumping. Just click on the keyboard icon and then press the key you want to assign. I'll just use the spacebar for jumping. And this is all we have to do for the jump. Click on the plus again and add a mapping for IA Move. Here things get a little bit more complicated. First, we want to assign the D key on the keyboard for right movement. And then we want to create another binding. And then for the other binding, we want to set the A key for walking left. Now both of these buttons do the same thing though, and we need to differentiate between them for walking left and right. Since we selected a 1D axis float here, we need to flip around the input for left and the A key. So here we can go to modifiers and add the negate modifier. By default, an axis 1D will point to the right, so for D we get the value of 1, but if we use the negate modifier for the A key, we'll get the value of -1 instead, which is what we want. But again, if we press play now, nothing really changed. We still need to tell the character to use the input mapping context and then also what code to execute when we trigger the IA jump or IA move. Open up the BP player and go to the event graph. We need to activate the input mapping context on begin play. Right click and get controller. Drag off from the return value and cast to player controller. Connect the line to begin play. From the player controller, drag off and look for subsystem and get the enhanced input local player subsystem. Here drag off and look for add mapping context. And then connect the lines. Very important, on the add mapping context, we need to assign our IMC platforming or this entire thing won't work. Now that this is set up, we can just move to the side a bit, right click and look for our IA jump. We can then expand this and drag off from started and use a print string that says jump, just to demonstrate how this works. Go further down and then just look for IA move. And here we can drag off from triggered and print string. And just drag in the axis value. Now go back and start the game. And very important, we need to click into the viewport with the mouse one time to start controlling the game. And now if we press space, you can see that it says jump. When holding A, it says -1 for left, and when holding D, it says 1 for right. Now that this is working, we want to put in the actual code to make the character jump and walk, and with Unreal Engine this is rather simple. For the jump, just delete the print string, drag off from started, and look for the jump function. Then drag off from completed and look for stop jumping. And this is the default setup for jumping and all it takes to make the character jump when we press space. To make it move, we can again just get rid of the print string here next to the IA move, drag off from triggered, and look for add movement input. Here we connect the axis value to the scale value. And we need to set the world direction. If we go back to the map and select the player start, we can see that the red arrow is the direction we want to go. If we drag around the red arrow, we can see that the X value is updating, and this means we want to move our character on the X axis. So for the world direction, we put in 1.0 on the X and leave Y and Z at 0. Now when we start the game and click into the viewport, we can walk left and right, and all of this might seem like magic to you, but the jump function and the add movement input function are nodes that Unreal Engine has prepared for us. These are things that are commonly used in all types of games, so there's no need for us to reinvent the wheel. Of course, right now there are still a couple of issues with our character which we'll solve step by step. But this was the general way you go about setting up inputs and adding new actions to a pawn. Let's now make sure that we transition properly between the idle, walk, and jump animation, since this will make the game feel much more complete. Open up the BP_player and look for the tick event. The tick event will be fired off on every single frame and is the best way to keep something like an animation state up to date. First, we just want to switch between the idle and walking state, and to determine if we need to switch or not, we only need to know if the character is currently moving or stationary. To do that, we can just right-click and get velocity. And then look for vector length. We don't really care about the direction in this case, and vector length will simply give us a value of 0 if we're not moving, or a positive value if we are moving. So here we can simply check for greater than 0. Then put a branch here, which basically is an if-else statement, if you're familiar with other programming languages. Then we can drag out a reference to Sprite, which is actually the Flipbook component. And here we can then call set Flipbook, and set the new Flipbook to fb_player_run. Then connect this node to the true output of the branch. You can also double-click these lines to create reroute nodes to organize the blueprint a little bit. Then we can just select all of this, Ctrl-C to copy, and then Ctrl-V to paste, and connect it to the false case. Here for the new Flipbook, we want to select the fb_player_idle. And now we can just go back to the map and press play to check this out. We are now correctly switching between the walk and idle animation if we are moving. Next up, we want to put in the jump, rise, and fall animation as well. First, we want to clean this up a bit, and we can select all of these nodes we use for switching between the run and the idle. If you can't select all of them at once, you can hold Shift or Control to get them in multiple goes. Then right-click one of them and collapse to function. Call this update animation and move it over. Now double-click to open it up. This still does exactly the same thing, but it's encapsulated nicely and a lot easier to maintain. Now at the place before we decide between the idle and run, we want to open up some space. Here we now look for isMovingOnGround, which is a method available on the character movement component. And here we can add another branch. Connect it, and then also connect the true output to what we were doing before. Because if we are moving on the ground, we need to decide between the walking and idle like we have been doing before. Now for the false case, we want another branch. And here we want to check if our character is currently going upwards or downwards. For this we can just get velocity. Right-click the return value and split struct pin. Now we need to know if we want to use the X, Y, or Z. Again, if we go to the map and click on the player start, we know that the blue arrow is up or down. And if we drag this around, we can see that the Z value is the one that changes. So back in the blueprint, we can then check for the return value Z and see if it's smaller than 0. This means that we are falling down or descending. So here we can copy paste this sprite and set Flipbook. And for the new Flipbook, select the FB player fall. Then copy paste this again. And in the false case, play the FB player jump rise. And now you can see that we can properly switch between the jump rise and the falling animation. A nice little trick to make the transition a little bit smoother is to not check for smaller than 0, but check for something around -100. That way we don't switch animations directly at the apex of the jump, but after descending a little bit. This just makes it feel a bit more natural in my opinion. And this is all it takes to set up animation switching for your Paper 2D flipbooks. For simple things like we did now, this method works just fine. However, once you make more complicated games with a lot more animations, this can be a bit hard to manage. For that reason, somebody made a free plugin called PaperZD, which adds support for animation graphs that make handling animation states much simpler. This is definitely something that will make your life a lot easier when making 2D games with Unreal Engine. I actually made a full 12-hour course about 2D game creation with Unreal Engine, in which I teach you how to create 4 awesome games. We start out slowly by creating a simple quick draw minigame, then move on to creating a classic arcade masher game, and the last 2 projects will make use of the free PaperZD plugin and will go into detail on how you can set it up and get the most out of it when making more complex games. We'll use this to create a platformer game with enemy AI and gimmicks, and lastly to also create an action platformer in a 2D-3D hybrid style that includes melee combat and some Metroidvania elements. So if you're interested in mastering Unreal Engine 2D, check out the discount link in the description. The next thing we want to do is make our character turn left and right when walking, because now we're always just pointing to the right. This is actually quite easy to do. Back in the BP_player, we want to go back to the event graph and look for our IA move event. After the add movement input, we want to right-click and get controller. Then drag off here and set control rotation. We can drag off from new rotation and look for select. Use the utilities select here. This acts very similarly to a branch, but in situations like this, it can be a bit easier to use. This will now basically just let us pick between two options for setting the character's rotation. And how do we decide this? Well, the action value will be something negative for left and something positive for right. So we can just drag off and check for greater than 0 and plug this into the index. Let's start with the true case. Drag off here and look for Make Rotator and select the one all the way at the bottom. If this is true, we want to point right, so for this we can just leave everything at 0. For the false case, again, make rotator. When moving left, we want to turn the character by 180 degrees on the z-axis, so here we can just put in 180. Now if we start the game and walk right, everything is fine, but if we walk left, you can suddenly not see the character anymore. This is actually a sign that the turning is working correctly. You can hit Shift and F1 to get the mouse pointer back and then click on Eject to see what's going on. We can see that the character is now correctly pointing to the left. However, the camera also turned with the character and is now on the opposite side of the tile map. Let's stop the game and fix this really quickly. On the BP player, go to the spring arm, and on the right side click on rotation. We want to set this to world, which will then show up as absolute rotation. And now if we try this out, you can see that we are properly turning left and right and the camera is ignoring the rotation of our character. But our character still feels very floaty and not fun to control. This is because the default settings on the character movement component are not that great. Open up the BP_player and select the character movement component. Here just look for gravity and set it to something like 3.0. Now if we play the game, you can see that the character falls much faster, but we also need to change the jump power to accommodate for that. Back on the character movement component, look for jump velocity and set this to 800. We can then also set air control to something like 0.7 to make the movement in the air more responsive. And all of these are just some values I found through trial and error that I believe make the character more fun to control. One more problem we have is that if we try to walk off the ledge, instead of falling instantly, we just awkwardly walk downward slowly. This happens because of the capsule component in the BP player, and capsules are really nice if you have stairs and slopes, but for things like these they can lead to problems. Luckily though, there's a simple setting for this on the character movement component. Just look for floor and activate use flat base for floor checks. And now we fall instantly, like it is the case with most 2D games. One last setting we want to adjust on the character movement component is the movement constraint. Even if we make a 2D game and only have an input set up for left and right, it could still happen through physics or forces that we are being pushed into the foreground or background. To prevent this, we can go to the character movement component in the BP player and look for constraint. Activate constraint to plane. And in the plane constraint normal, we need to set the direction in which we want to constrain the movement. Again, if we look at the player start, we can see that the green axis is the one which we want to prevent movement in. And this is the y-axis. So on the y-axis, we just set the plane constraint normal to 1.0 to activate it. And now we can be absolutely sure that the character will never leave the original lane. And this is all we have to do to set up the base for a 2D game in Unreal Engine. This might seem like a lot, and yeah, it is a lot to remember, but once you've done this a couple of times, it feels like second nature. However, I actually made a free template that is open source that already has all of this set up. You can easily add this to Unreal Engine and create all of your new 2D projects from it, so you don't have to go through all of these steps every single time you want to make a 2D game. But it's very important that you followed along with this tutorial and did everything at least once, so you can understand how all of these different things work and expand upon them. And as a patron, you can also get 2 more advanced templates that use paper-ZD animation graphs, and there is one version for a 2D 3D hybrid side-scroller and another one for a 2D 3D hybrid top-down game. And now to wrap things up, we can just go into the tm_stage and expand upon our map to make things look a bit nicer. Making tile maps isn't something I'm necessarily great at, and you can just go wild on your end and use all of the tiles we have available here to make a stage you like. I'll add a couple of more layers to add clouds, props, decorations, and other things to dress up the stage a little bit. And this is the small stage I ended up with after playing around with it for a little bit. And I hope you enjoyed this introduction to making 2D games with Unreal Engine. As always, thanks to my amazing patrons.